So we've really got some like terms to combine. We've got a 6t to the fourth. Later on, we've got what's really a negative 9t to the fourth. So what do you have? Negative 3t to the fourth. We've got a t cubed. Later on, we got a minus 3t cubed. So minus 2t cubed. A minus 6t, that's it. And a minus 1. Very pessimistic problem. Everything's negative. Yeah. Well, you can't cancel. Right. You can cancel factors, but not terms. This is a difference of square cubes, I guess. So I suppose it might factor and do something. I don't see it though. I'm doubting it.
So usually you just want us to leave them like that?
Yeah. If you're hey, I just got an idea. If you're really curious as to whether or not there's going to be something down here that'll cancel in the top, because there's really no point in really pursuing this if nothing's going to cancel. Well, what number would give you a 0 in the bottom? If t were 1, you'd have a 0 in the bottom. Plug in 1 up top. You're not getting 0 up top then, are you? So if we aren't getting 0 over 0, we can use our calculus knowledge. If we're not getting 0 over 0, we're not going to have a removable discontinuity. And if there's no removable discontinuity, there's nothing to cancel. How about that? I'm way more impressed with that than most of you, but that's all right. Pick up the pieces and move on. But that would be your derivative. Skip that.
So wait, will that come in handy to know all that later?
What's that?
Will it come in handy to know all that later?
No more handy than it was right now. It's like having an extra roll of duct tape. You just never know. You know, you wake up tomorrow, you probably won't need it, but someday you might. Good to have it there. Especially when students go in hands. Okay.
How's that new microphone actually?
It's old school.
What is it?
Right now, Mr. Adams sounds like, stop tapping it. All right.
What is it supposed to be, Mr. Striker?
I don't know. It's just my grandfather's. My grandma gave it to me. She's like, "Do you want one of these?" And I'm like, "No, I don't know what it is." And she didn't either, so I took it. I don't even know if it's supposed to be like this or like this or like that. I don't know. It's kind of cool.
It's for the ancient auditor.
Let's find the derivative with respect to x of 3 over x squared. Two different ways. Yeah.
Can I ask a dumb question?
Shoot.
I know that it needs to respect to x. What is it? Is that like an annoying or
It's just, this means derivative with respect to x. So differentiate it. Whatever you do f prime of x, we're automatically doing with respect to x.
So just find the derivative?
Yep.
That's never really good.
Yeah. If you differentiate with respect to like y or something, then, well, I tell you, but.
Oh, fair enough. Fair enough.
It would just, you wouldn't have, your derivative of x wouldn't be 1, it would be x prime, for lack of a better phrase. So you'd have to write an x prime every time. We'll actually look at problems like that. Alright. Should we do quotient rule? Because it's a quotient?
Oh my gosh.
Q rule. Let's do it. First things first, what do we do? Well, first thing you actually want to bring the x squared right up top as it is. So that'll give us x squared times derivative of the top, which is 0. Well, that'll clean things up for us a little bit.
Minus 3 times
Go on board. Train's leaving the station. You want to be on the train, not on the track.
I'm confused.
Minus, top we got what? 3. Derivative of the bottom? 2x.
Grab something.
And the bottom squared is no longer x squared. X squared squared is x to the 4th. So this would be like saying, this first term is obviously 0. This would be minus 6x over x to the 4th. And that will reduce a lot, a couple ways.
Is that what it means by 2 different ways?
No, it's, well, it's like reduce quotient rule is one of our ways, and we'll start over with a different. Yeah.
Let's try.
Actually, it'll reduce one way.
Cancel it out.
Yeah, really the negative 6 is on top. There's 3 more x powers on the bottom, so we'll just call it negative 6 over x cubed.
So I was confused. You said a couple of ways.
For some reason, I was thinking the 4 was out front there. So I thought 6/4 was reduced. And I looked at it again and realized that was wrong. I've spent way too much time talking about that already. It's embarrassing. I want to move on. If we wanted to do this another way, what could we do? What would we have done a week or 3 days or 3 school days ago?
Can't we just put,
Bring
the
square
x
off
freeze
of-
negative
As a negative.
Yeah. So we could have used power rule. So 3x squared would have been 3x to the negative 2nd. And that would have become, I won't use an equal sign, because this is f, and this is going to be f prime, really. So I'll use an arrow to say something different. Then we could have just had a negative 6 out front. X to the negative 3rd is our power. And if you throw the x to the negative 3rd in the denominator, you would have gotten, of course, the same thing.
Oh, jeepers.
Like, I love these great computers. I went to
Hey, let's do one more.
So we got
We're going to do f prime of theta. If f of theta equals x squared, no, not x squared, what am I doing? Theta squared, tangent theta.
Did somebody cry?
I don't like when they use.
Yeah,
What's the tangent?
good question. We're going to eventually need to know the derivative of tangent, and we don't really have that at the ready.
So this side
No.
I think
Yeah, it's like, so I was like, how does quotient rule come into this? Well, tangent's just sine over cosine. So let's rewrite this thing as theta squared sine theta over cosine theta. And the sine over cosine portion is taking the place of what used to be called tangent. And it's a quotient now, so we'll use quotient rule.
Do it.
F prime. First things first, what happens?
Bottoms up.
Yep. Bottoms up. So cosine theta is your first factor. I'm just going to put it in parentheses because I feel like doing it, I don't know, putting a nice warm blanket around it. Times the derivative of the top, right? And in order to get the derivative of the top, oh crap, the top's the product. So we're going to use product rule to do this part. It's not that. So let's do the derivative of the top. So start with theta squared, right? Well, alright, you can go that route. I'll usually start with what I see times the derivative of the second and then come back. Yeah.
Okay, and that's sine.
Product rule is just first thing times derivative second plus then come back the other way. So first thing is theta squared times derivative of sine, which is going to be cosine theta, plus, and now we come back the other way. Yep. Yeah, it's going to be sine theta as is times this derivative, which is 2 theta. So is it okay with you if I just put 2 theta sine theta?
Yeah.
So product rule again is first thing as is times derivative of second, which gives you that, then a plus, then it's the second thing as is times the derivative of the first, and that's where the 2 theta came from, it's the derivative of the first. And it's all over cosine squared. I'm not even done with the quotient rule yet, am I?
No,
Sorry.
that's
You said that and I didn't trick
But
back.
like why can't you just go like cosine theta and then do 2 theta sine, or 2 theta cosine theta? Like why take
Because this is theta squared times sine theta. It itself is a product, so you've got to use product. Okay. Yeah, I'm not even done with the numerator yet. All I've done so far is this was the bottom, bringing the bottom up to the top, times the derivative of the top. I'm not even, yeah, we haven't gone to the, take the derivative,
we don't.
or take the top as is. Yeah, so it's, I'm going to kind of do the other order, but yeah. I'm going to take the top as is, times the derivative of the bottom, and that's a negative sine theta. Zoinks.
Really?
Should we clean this up a little? Maybe we can. If you distribute this in, you get theta squared as your non-trig portion. And then you get cosine squared theta with it. Everyone okay so far? Oops, it's not plus. Then we got, well actually look, we got all this stuff being multiplied. You got a negative times another negative. I'm just going to jump and call it plus. Yeah.
What happened to the cosine times the 2 theta sine theta?
Yeah, I totally forgot to distribute it to the second loop, didn't I?
Yeah.
Good catch, thank you. So we're going to have, this is 2 theta, sine theta, cosine theta. You can put them in whatever order I guess you want.
What's going on anymore?
It's just algebra.
Our answer is connected.
This last sign will be a plus, because now we're doing a negative times another negative. That's why it kicks over to a plus. You get theta squared, and then sine squared theta. And the whole ugly thing is over cosine squared. As far as reducing that, I don't think it's going to really reduce.
So we're done?
Yeah, I mean, there's probably some wild trig property that we've all forgotten about that'll reduce it, but I'm not